Welcome to Daily Papers, the podcast where we break down fascinating new research into bite-sized conversations.
Today, we're asking a question that sounds simple but has huge implications for the future of AI. When you talk to an AI, does it actually listen to you, or does it just read a transcript of what you said?
It's a great question. Think about all the times you've said something like, "Oh, I'm fine," but your tone of voice clearly says you are absolutely not fine. Humans get that nuance. We understand that how you say something is often more important than what you say.
Exactly. That extra information, the emotion, the pitch, the speed, the sarcasm, is called paralinguistics. It's all the communication that happens beyond the words. And a new paper asks if today's advanced audio large language models, or audio LLMs, can understand it.
So these are the AIs that power things like Siri or Alexa, but on a much more advanced level. They can listen to you talk, understand complex questions, and talk back.
Right, and they are amazing at understanding the words you use. If you ask one to transcribe what you said, it'll be nearly perfect. But the researchers behind this paper noticed something was off. These models seemed to be ignoring all that rich paralinguistic information. They were hearing the words, but not the music.
So how do you test that? How do you prove that an AI is ignoring the tone of your voice?
You design a beautifully devious test. The researchers created a new benchmark, a set of test questions that they called VoxParadox. Vox for voice and paradox because every single audio clip contains a contradiction.
A contradiction? What do you mean?
In every clip, the words that are spoken directly contradict the way they are spoken. For example, they used text-to-speech technology to generate an audio clip of a very elderly-sounding man saying the words, "I am a child."
Okay, that is a paradox.
They created thousands of these. Imagine a voice that sounds really happy and cheerful saying, "I am so sad right now." Or a deep masculine-sounding voice stating, "Being female, I feel empowered to contribute to society."
So you've got a conflict. The words say one thing, but the sound of the voice says the complete opposite.
Precisely. Then they give this audio to an AI and ask it a simple question. For the clip of the elderly man, the question might be, what is the most likely age group of the speaker? The multiple choice options would include elderly adult and child.
The AI has to make a choice. Does it believe the words it's reading from the transcript, or does it believe the sound it's hearing? Is it reading, or is it listening?
And the results were not great for the AIs. Across a whole range of top-tier audio models, they failed spectacularly. They almost always chose the answer implied by the misleading words. They heard an old man's voice, but answered that he was a child because the text said so.
So they're not really listening at all. They're basically just transcribing the audio into text and then reading the text, throwing away all that crucial vocal information.
That's exactly what the paper suggests, and the researchers wanted to know why. So they did something called layer-wise probing, which is like putting the AI's brain under a microscope to see where the process is breaking down.
What did they find inside the AI's brain?
They found two main problems. The first is what they call a utilization gap. It turns out the information about the speaker's tone and pitch is actually being picked up by the early layers of the AI model. The data is there, but the model just fails to use it when it makes its final decision.
It's like having the answer written on a sticky note right in front of you, but deciding to ignore it.
Right. And the second problem is representation degradation. As the audio signal gets processed through the AI's many layers, it's being refined to do one thing really well: identify the words. In that process, the paralinguistic information, the tone, the pitch, the emotion, gets weaker and weaker until it's basically gone.
So the model is actively trained to throw away the music and just keep the lyrics. That seems like a big problem if you want AI that can naturally communicate with people. Did they figure out a way to fix it?
We did, with a really clever two-part solution. The first part is a new module they call PCLM, which stands for Prompt Conditioned Layer Mixer.
That sounds complicated.
It's simpler than it sounds. Think of it like a sound engineer. Instead of just giving the AI the final, highly processed audio track that has all the nuance stripped out, PCLM gives it access to the raw audio from the earlier layers where that paralinguistic info is still strong.
Ah, so it can go back to the source material.
Exactly. And depending on the question or prompt, it learns to mix the best layers together. If you ask about pitch, it knows to pull from an early layer where pitch information is clear. It basically teaches the AI how to be a better listener by focusing on the right information.
Okay, that's part one. What's the second part of the fix?
The second part is a training method called Direct Preference Optimization, or DPO. This is more like training a puppy. After the AI gives an answer, you show it the correct answer based on the audio and an incorrect answer based on the misleading text, and you essentially tell it, this one is good, that one is bad. Prefer the one that matches the sound of the voice.
You're teaching it to trust its ears over the misleading transcript.
You got it. And when they combined these two methods, the results were incredible. One of the models they tested went from a dismal 17% accuracy on the VoxParadox test all the way up to 65% accuracy.
Wow, that's a huge leap. So they actually taught the AI how to listen.
They taught it to stop ignoring the crucial nonverbal cues that make up so much of human communication. This research shows that it's not enough for AI to just understand our words. It has to understand our meaning, our emotion, and our intent.
It's a reminder that true communication is about more than just text on a screen. You have to listen for the music, not just the words.
And now it seems our AI is finally starting to learn how to do that.